skincare industry is actively seeking novel, evidence-based ingredients. Canal oil, rich in essential fatty acid and tocopherol, shows exceptional promise for hydration and photoprotection. However, a critical disconnect exists. While its phytochemistry is well documented, its real-world therapeutic efficacy within a stable, finished cream formulation remains between unproven. This gap between laboratory potential and commercial application is what our study addresses. We bridge this device by not just formulating a Kenaf seed oil-based cream, but by integrating comprehensive phytochemical evaluation with rigorous therapeutic evaluation to validate its true skincare potential. Thank you. Our study integrated phytochemical profiling and therapeutic evaluation of Kenaf seed oil for advanced dermal cream formulation. Is positioned by within contemporary research. Recent work by Muhammad et al. 2022 successfully extracted and confirmed the antioxidant activity of Kenaf seed oil, reinforcing its bioactive potential. Similarly, Chu and Yam et al. 2020 highlighted its specific application as a cosmetic ingredient. However, these modern studies, while valuable, still align with the traditional focus on extraction, characterization, and in vitro activity. The persistent gap is the lack of evidence for its in situ therapeutic performance within a finished, stable cream. Our research is designed to fill this gap by formulating the oil into dermal cream and conducting a direct efficiency evaluation, moving beyond characterization to functional validation. Thank you.
Similarly, Nyam et al. 2009 reported that Kenaf seed oil exhibits physicochemical characteristics comparable to conventional vegetable oils used in skincare products, suggesting its suitability for topical applications. Their findings also indicated that processing conditions may influence the retention of bioactive compounds, particularly heat-sensitive antioxidants. Furthermore, studies on plant-derived oils in dermatological formulations demonstrate that the effectiveness of bioactive compounds depends not only on their presence, but also on formulation, stability, and delivery efficiency. As emphasized by Marriott 2013, refining processes can improve oil clarity and shelf stability, but excessive heat exposure may reduce certain thermolabile phytochemicals. Despite these findings, most previous studies primarily focused on chemical composition analysis rather than integrating phytochemical profiling with therapeutic performance in formulated creams. Therefore, this study builds upon the existing literature by combining chemical profiling and functional evaluation to scientifically validate the therapeutic potential of Kenaf seed oil cream.
Ladies and gentlemen, our methodology focuses on developing a stable and effective Kenaf oil-based cream. The process begins with the preparation of Kenaf seeds, which are carefully cleaned, dried, and ground into a fine powder to enhance extraction efficiency. During the early stage of the study, a water-based extraction method was explored as a primary approach. However, this method was found to be less effective in producing a sufficient yield and purity of Kenaf seed oil for cream formulation, because while we doing our experiment, we got a crude oil beside of a normal oil, which is we want to use a normal oil because it's more pure than a crude oil. As a result, it was not selected as the primary extraction method to product development. To ensure higher oil recovery and consistent quality, the success extraction method was applied. In this process, powdered Kenaf seeds were subjected to continuous solvent extraction using an hexane. The extracted oil was then separated from the solvent to rotary evaporation. Producing pure Kenaf seed oil, the oil was stored in airtight, dark containers to prevent oxidation and maintain its quality. Once the oil was obtained, it was formulated into a topical cream through an emulsification process. The oil phases, consisting of Kenaf seed oil and emulsifying wax, was heated and combined with a heated water phase under continuous basin to form a stable emulsion. As the Mexico, vitamin E, fragrance, and preservative were added to extend stability and extend shelf life to final cream was stored under suitable conditions to preserve its consistency effectiveness.
So, what is actually hiding inside the kenaf? In this study, we analyzed two samples which are MRSAM-1 and MRSAM-2 to identify bioactive compound with antioxidant, antimicrobial, and anti-inflammatory potential. So, we brought in GCMS. What is GCMS stand for? GCMS is gas chromatography mass spectrometry. It separates, identifies, and exposes every component in the sample. MRSAM-1 show a higher phenolic content with major compounds like naphthalenol and sterol, suggesting strong antiseptic and anti-inflammatory properties. Meanwhile, MRSAM-2 was dominated by linoleic acid along with a wider range of fatty acid, making it more suitable for skin barrier repair and moisturizing application. But both samples also contain trace amounts of carbaryl, which highlight the importance of purification before any cosmetic or therapeutic use. So, GCMS made it clear. Different role, different strength, same conclusion. GCMS help us choose the right sample, the right way, and safely.
Many commercial cosmetic products contain synthetic ingredients that may cause skin irritation, dryness, and long-term sensitivity. This concern highlight the need for safer and more effective skincare effectiveness. Our Kenaf oil-based cream addresses this issue by using a natural oil rich in essential fatty acids and antioxidants, supported by a carefully selected extraction and formulation process. By prioritizing oil quality and product stability, our formulation offers a more skin-friendly and sustainable alternative to conventional cosmetic product. We hope that this product can promote healthier skincare practices, encourage innovation using natural resources, and contribute positively to society through the development of safer cosmetic solutions.